You know, when you hire a new human employee, there is this inherent expectation of permanence.
Right.
You give them a physical dex, you hand them an ID badge, you grant them access to the corporate drive, and when they come into work on a Tuesday, they remember exactly what you talked about on Monday.
Yeah, they just pick up right where they left off.
Exactly. They have a continuous existence within your company, but then you look at how we have historically interacted with artificial intelligence over the last few years.
It's been very different.
Completely different. You open a chat window, you ask a complex question, you iterate, you get an answer, and the second you close that browser tab, the AI practically gets amnesia.
Totally wipes the slate clean.
Yeah. Everything you just built together vanishes into the ether. It has been entirely ephemeral.
It is the absolute definition of a stateless interaction. And for a very long time, we just, we accepted that limitation. We treated generative AI like a brilliant, incredibly fast, but profoundly forgetful intern.
Well, looking at the landscape of AWS Bedrock updates that dropped just between March 22nd and March 28th of 2026, it is clear that era is over. So welcome to the deep dive.
Glad to be here.
Our mission today is to explore a massive fundamental paradigm shift. We are no longer just talking about conversational chatbots. Generative AI is actively shifting towards secure, stateful, autonomous digital workers that are embedded deeply into the very foundation of enterprise infrastructure.
And to make that shift happen, to go from a forgetful chatbot to a persistent digital employee, you really have to upgrade the entire technology stack simultaneously.
Right. It's not just a software patch.
Not at all. You need highly specialized foundational brains. You need entirely new memory systems so they don't forget their tasks. And you have to push those upgrades all the way down to the physical silicon, the bare metal, powering it all.
So let's start at the top of that stack, the foundational brains. Because before an AI agent can execute a complex multi-day task for you, it needs specialized perception.
It needs to be able to see and reason.
Exactly. The era of just throwing one single massive generalized model at every possible problem is ending. It is making way for highly specialized brains.
Which brings us to a major release from Ryder in collaboration with AWS. Ryder's Palmyra Vision 7B model just became available natively on Amazon Bedrock.
Now, 7 billion parameters is, well, it's relatively small in the grand scheme of AI models. Why does an enterprise want a smaller vision model?
It really comes down to cost efficiency and specialization. Palmyra Vision 7B was trained on something called a PixMo dataset,
Okay.
specifically a 1 million pair dataset. And because it was trained so intentionally, it gives enterprises a specialized tool that is incredibly good at very specific visual tasks.
Like what kind of tasks?
Think about extracting handwritten text from a scanned Post-it note or, analyzing the layout of user interface screenshot.
Oh, wow. So if you are a logistics company processing thousands of handwritten warehouse receipts a day, you do not need to fire up a trillion parameter supercomputer just to read the handwriting.
Exactly. You use the smaller, cheaper, specialized tool. It does the job perfectly without burning through your compute budget.
But that raises the obvious next question. What happens when you do need massive, complex reasoning?
Right.
If I need an AI to analyze a highly complex tax document, a small model is not going to cut it.
No, it's not. And that is where the architecture of the models themselves is changing. NVIDIA just added their Lemmatron 3 supermodel to the unified Bedrock API. And this thing is a beast.
How big are we talking?
It is a 120 billion parameter model.
Wait, hold on. If I'm trying to save on compute costs, why am I loading a 120 billion parameter model? Aren't we right back to bankrupting the enterprise compute budget?
You would think so, but Lemmatron 3 Super uses an open hybrid mixture of experts architecture.
The MOE architecture.
Exactly, commonly called MOE. Even though the model contains 120 billion parameters in total, it only activates 12 billion parameters for any given token of text it generates.
Okay, I want to make sure I'm visualizing this correctly. Think of this mixture of experts architecture like a massive global corporate law firm.
I like that.
So the firm itself has 120 billion parameters, or in this analogy, 120,000 lawyers covering every conceivable legal specialty. You got maritime lawyers, patent lawyers, tax lawyers. But when you, the client, have a very specific tax issue, you do not pay the entire firm to sit in a room and look at your file.
You go broke if you did.
Exactly. The firm's receptionist routes your file only to the specific 12,000 lawyer department that specializes in tax law. You only pay the hourly rate for the partners actually working on your case.
That is precisely how the routing mechanism works in an MOE model. The system intelligently routes the computational workload only to the expert neural networks within the model that are best suited to answer that specific prompt.
That's brilliant.
It really is. By only activating 12 billion parameters at a time, you enable incredibly high-throughput reasoning, complex summarization, and heavy code generation for multi-agent applications. You get the vast knowledge capacity of a massive model with the inference speed and the operational cost of a much smaller one.
Okay, that makes total sense for text and static images. But what about video? Because video has historically been the absolute most computationally crushing format to analyze.
Oh, no doubt.
If I have an AI agent whose job is to monitor a continuous security camera feed, how is that mathematically possible without racking up astronomical token costs?
Well, AWS literally just published a reference solution to solve that exact bottleneck.
Yeah.
They outlined 3 distinct architectures: frame-based, shot-based, and sequence-based processing.
And this is specifically for video.
Yes, specifically for analyzing video using models like Amazon Nova and 12 Labs Marengo. And the secret sauce here is a mechanism involving what is called a cosine distance threshold.
Okay, stop right there. Cosine distance threshold of 0.2 was the exact metric AWS highlighted. But what does that actually mean in plain English? How does vector math save me money?
Let's break it down. When an AI looks at a frame of video, it doesn't see a picture like we do. It turns that image into a mathematical coordinate, a vector.
Okay, I'm with you.
Now imagine a graph. If the AI plots the coordinate for frame 1 and then plots the coordinate for frame 2, it measures the distance between those 2 points. That is the cosine distance.
Ah, okay.
If the distance is 0.2 or less, the math is essentially telling the AI, hey, the angle between these 2 coordinates is so incredibly small that these 2 pictures are effectively identical.
Oh, so if a security camera is staring at an empty hallway for 4 hours, the AI processes the first frame, and then for the next 4 hours, the cosine distance between every subsequent frame remains under 0.2.
Exactly. So this system just automatically ignores them. Yeah, it intelligently drops the redundant video frames before they are ever processed by the heavy reasoning model. You only spend compute tokens when the cosine distance spikes.
Meaning someone actually walked into the hallway.
Exactly.
Yeah.
This single mechanism allows developers to perform natural language video search at an absolute fraction of traditional token costs.
That is wild. Okay, so we have the brain sorted out, we have specialized vision, we have cost-effective massive reasoning, and we have efficient video processing. But brains are really only half the equation for a digital worker.
Sure.
If they are going to do actual work, they need memory.
Which brings us to what is arguably the most significant architectural shift of the week. Amazon Bedrock AgentCore Runtime Managed Session Storage.
That's a mouthful.
It is, but this is the feature that gives the AI its state, its continuity.
Right now, this is in preview across 14 AWS regions, right?
Yes.
And what it does is allow agents to durably persist their file system state. This includes source files, installed packages, and build artifacts. They are completely preserved across stop and resume cycles.
Let's put this into context for you, the listener. Previously, when an AI session ended, the micro-virtual machine that was spun up to run your task was torn down.
Just completely deleted.
Everything the agent did, any scratch pad it used, was wiped clean. Now, AgentCore allows these agents to maintain up to 1 gigabyte of persistent storage per session.
That's huge.
And that storage is retained for up to 14 days of idle time.
Think about your own engineering team. Imagine handing a digital agent a massive code-based migration on a Friday afternoon. You want it to analyze the code, test dependencies, and start refactoring.
Right.
Because it now has persistent storage, it can work on it continuously. If it needs to pause to wait for an API rate limit to reset, or if you pause it to review its progress, it doesn't lose its work.
It remembers everything.
It is a permanent 1 gigabyte hard drive for that specific session. It can execute complex, multi-day engineering workflows.
It fundamentally changes what you can assign an AI to do.
Okay, but I have to push back a little here, just purely logistically. If I am running an enterprise and I have thousands of autonomous agents spinning up their own file systems, writing gigabytes of data, and pausing and resuming over 2 weeks, how does a human engineering team keep track of that overall workflow?
It sounds like it would be a mess.
It sounds like absolute chaos. Who is managing the managers?
Well, you cannot just leave them running blind. AWS knew this, which is why they simultaneously rolled out an update to AWS Step Functions.
Okay.
They added over 1,100 new API actions to their visual workflow service, specifically to integrate with Amazon Bedrock AgentCore.
Visual workflow, meaning you are literally drawing the process out.
Yes. Developers can now run multiple AI agents in parallel using visual map states. Instead of writing incredibly fragile, thousands of lines long integration code to manage these agents, you just build a visual flowchart.
That is so much easier.
It really is. You can completely automate the provisioning, the monitoring, and the destruction of the agent infrastructure. If Agent A finishes its task, Step Functions visually routes the output to Agent B, wakes Agent B up, and sets it to work.
Wow.
It gives human managers an orchestration layer to supervise fleets of digital workers.
That orchestration scale is massive. But even with good management, you still need to train these agents to behave according to your specific corporate standards, right?
Right. Training is the final piece of the software puzzle, and it has historically been a huge bottleneck. This week, AWS released a technical walkthrough for using Bedrock's reinforcement fine-tuning, or RFT.
And this is via standard OpenAI-compatible APIs.
That's correct. They are utilizing something called lambda-based reward functions.
And they are doing this on open weight models like GPT-OSS20B and QM3. But I want to zero in on the methodology here because the documentation heavily referenced algorithms like GRPO, generalized reward policy optimization.
Yes.
What does that actually mean for the developer trying to train an agent?
It means bypassing the worst part of AI training, which is hand-labeling data. Historically, if you wanted an AI to respond in a specific format, you had to manually write thousands or millions of examples of the correct way to answer.
That takes forever.
It took months and massive human labor. GRPO is a mathematical approach to feedback.
So instead of showing the model a million examples of a right answer, you are giving it a grading rubric.
Exactly. You give it a small set of prompts, and you write a lambda function, a small piece of code that acts as the grader.
Okay.
When the model tries to answer, the code checks the answer. Did it use the right formatting? Did it avoid prohibited words? If yes, the algorithm mathematically rewards the model.
So it figures it out on its own.
Yes. It allows developers to iteratively align these models purely using automated feedback. It is drastically faster and cheaper.
Okay, so if we take a step back, we have fleets of intelligent agents. They are holding gigabytes of memory for weeks at a time. They're being visually orchestrated in parallel and continuously fine-tuned automatically.
It's a lot.
I have to wonder aloud, what is actually physically running this? The sheer scale of parallel stateful computing happening here is hard to fathom. We are talking about millions of concurrent micro-virtual machines.
And that takes us right down to the bare metal, the heavy silicon lifting required behind the scenes. This week, we got an incredibly rare look inside the physical infrastructure when tech journalists toured AWS's Trainium lab down in Austin, Texas.
The numbers coming out of that tour are staggering. AWS and Annapurna Labs confirm they now have 1.4 million custom AI chips deployed globally.
That is a massive footprint.
And specifically, their newer generation, Trainium 2, is currently handling the vast majority of all Bedrock inference traffic.
To understand why a custom chip matters, you have to look at the physics of the server racks. These are liquid-cooled Tren 3 Ultra servers, and the chips are fabricated at a 3-nanometer scale.
Break that 3-nanometer metric down for me. Why does the physical size of the transistor change the economics for the person ultimately paying the AWS bill?
It is all about the distance electrons have to travel. When you shrink the fabrication down to 3 nanometers, you pack more transistors into a vastly smaller space.
Right.
The shorter distance the electrical signals travel, the less resistance they encounter. And less resistance means less power is wasted as ambient heat.
And heat is the absolute enemy of data centers.
Exactly. Heat forces the chips to throttle down their speed. And removing heat requires massive amounts of electricity for air conditioning.
So you're paying twice.
Yep. By moving to 3-nanometer custom silicon and directly cooling the chips with liquid, AWS removes the thermal bottleneck. The chips run faster, constantly, on less power.
Wow.
The result is up to a 50% lower cost for comparable AI performance. That physical hardware efficiency is what directly enables AWS to lower the inference pricing for Bedrock enterprise customers. It makes running fleets of agents financially viable.
So the physics of the silicon enables the economics of the agents. That makes a lot of sense. But giving these AI agents massive compute power, persistent memory, and the ability to execute multi-day workflows, it sounds like an absolute corporate security nightmare if it is not governed properly.
Oh, it absolutely is. With incredibly capable autonomous agents comes a need for incredibly strict, unbypassable adult supervision.
Yeah.
Which is why the safety and governance updates this week are so critical. AgentCore just added native support for Chrome enterprise policies and custom root certificate authorities.
Okay, so they are treating the AI's browser like a human employee's browser. I get applying Chrome policies, you can disable password managers, or block the agent from accessing unauthorized external URLs to prevent data leakage. But explain the custom root CA part. Why do I care about certificate authorities?
Think about where the most sensitive data in your enterprise lives. It's usually behind a firewall, accessible only via internal tools.
Like private Jira server or something.
Exactly, or an internal HR database API. Those internal servers use secure connections, TLS, which rely on certificates to prove they are legitimate. But because they are internal, they use certificates signed by your company's own IT department, not a public authority.
Ah, okay. So if the AI agent doesn't know to trust my internal IT department's certificate, it physically cannot connect to my internal tools. It just gets blocked by the firewall's security protocols.
Precisely. By allowing administrators to explicitly inject custom root CAs into the AgentCore environment, you are giving the AI the cryptographic badge it needs to securely navigate your private corporate intranet, entirely over encrypted channels. It brings the agent fully inside the corporate trust boundary.
That is so essential. But governance isn't just about locking down the network connections. It is also about tailoring the AI's behavior based on exactly who is interacting with it. And AWS published a fascinating serverless blueprint this week for building age-responsive, context-aware AI using Amazon Bedrock guardrails.
This is a brilliant architectural approach. What this blueprint does is dynamically map incoming user requests to one of 5 specialized Bedrock guardrails, and it routes them based entirely on the user's profile.
Okay, so it knows who is talking to it.
Exactly. For example, the system instantly knows if the incoming prompt is from a child, a teen, or a healthcare professional.
What I love about this is where the interception happens. It happens at the infrastructure layer, before the prompt ever touches the generative AI model.
And why that matters is security against prompt injection. If you rely on the AI model itself to remember the rules, say, telling it, hey, remember you were talking to a kid, a clever user can trick the model into forgetting that rule.
Right, they just prompt engineer their way around it.
Exactly. But by intercepting the prompt at the infrastructure layer, the routing is enforced by hard code. It cannot be bypassed.
It is exactly like a theme park fast pass system based on colored wristbands. Depending on the color of the wristband you scan at the gate, the physical gates automatically route you away from the intense adult roller coasters and funnel you straight into the kid-safe zones.
I love that analogy.
And it does this without relying on the rider to read the rules and without relying on the roller coaster operator to check your ID. The physical infrastructure of the park just enforces the routing.
And that enforced routing is what guarantees strict COPE-PON compliance for children's privacy, while simultaneously ensuring that when a verified doctor logs in, dense, unfiltered clinical data is allowed to pass through freely. You are not forced to water down the AI for everyone just to keep it safe for a few.
That is huge for enterprise adoption.
Yeah.
So if we synthesize everything we have discussed today, we have highly specialized models, we have multi-day stateful memory, we have visual orchestration managers, we have custom 3-nanometer silicon driving down costs, and we have infrastructure-level governance locking it all down.
It's the complete package.
It is. But the final question I have is, who is actually adopting this at enterprise scale right now? Is this all theoretical, or is the market actually moving?
Oh, the market is moving incredibly fast, and we saw 2 major indicators of that this week. First, looking at global expansion, Amazon Bedrock officially launched generative AI inference in the Asia-Pacific, specifically the New Zealand Auckland region.
Okay, offering local cross-region inference for models like Anthropic Claude and Amazon Nova 2 Lite. But why is a regional launch in New Zealand significant on a global scale?
Because of strict data sovereignty laws.
Ah, right.
Many government agencies and highly regulated local enterprises have been entirely blocked from adopting generative AI because their national laws state that citizen data physically cannot cross the national border for processing.
So they were just stuck.
Exactly. By deploying the physical infrastructure locally in Auckland, AWS fulfills those strict data residency requirements. It unlocks public sector adoption that was previously frozen.
That opens up a massive new market. But the biggest validation of enterprise adoption didn't come from a regional rollout. It came straight from the top of AWS itself. AWS CEO Matt Garman made a massive announcement this week.
It was a 2-part revelation, really. First, Garmin confirmed a planned $200 billion in capital expenditure for 2026.
$200 billion. That is staggering.
And it is specifically to support the infrastructure for over 100,000 companies building on Bedrock. But the second part is even more telling. Concurrently, AWS is deploying their own internal Bedrock AI agents to autonomously handle tasks that were previously executed by highly paid technical specialists in their sales and cybersecurity divisions.
See, that is the ultimate proof of concept. The sheer scale of that capital investment is one thing, but when a massive hyperscaler like AWS restructures its own internal human workforce using the exact same agentic tools it is selling to the public, it sends an undeniable signal to the market.
It really does.
They view this stateful, agentic Bedrock platform not just as a software product they sell to clients. They view it as the core engine restructuring their own long-term revenue and operations.
Yeah, to quickly recap the journey we have taken through this week's data, we have watched the technology move from cost-effective vision models capable of reading handwriting to autonomous digital agents equipped with gigabytes of persistent memory.
It's been a massive leap.
We have seen these agents governed by traditional corporate IT policies, orchestrated by visual mapping tools, and running efficiently on millions of custom fabricated silicon chips.
It is a profound evolution. And as we wrap up, I want to leave you, the listener, with a final thought to ponder. As these agents become fully stateful, completely persistent, and governed by the exact same IT policies as your human staff, the fundamental core unit of cloud computing is shifting beneath our feet.
We are no longer just managing static virtual servers or deploying isolated containers.
No, we are managing continuous sessions of digital employees. And that raises a massive question for the future of enterprise software. What happens to traditional SaaS software licensing?
Oh, that's a great question.
What happens to your corporate IT structures when the user assigned to an expensive enterprise license is actually an AgentCore micro-virtual machine, a digital worker operating 24 hours a day, 7 days a week, that never logs off, never takes a weekend, and never forgets a file? When you open your dashboard tomorrow, you are no longer just pulling up a tool. You are logging in to supervise a digital colleague who has been working at their desk all night.
It's a completely new world. Thank you for joining us for this deep dive.
We encourage you to look at your own workflows and ask yourself which of your processes are about to shift from a software tool you use to a digital worker you employ. The cloud has evolved from a place where we store data to a place where we employ intelligence. Stay curious, and we will see you on the next deep dive.